Hello friends, how are you? I hope you all are well. After a long gap, I am preparing video due to my personal problems, whatever it may be. Keeping an eye with the summer holidays, I decided to prepare some videos over IIT Foundation, which one will help different students, especially from class 6th to class 11. So, today's topic is measurement units, dimensions and vectors. In this video, I am going to explain specially about the dimensional formula. See here. Dimensional formula. What is dimensional formula? You know that three fundamental quantities. One is the length, one is the mass, one is time. Here, length can be represented by L, mass can be represented by M, time can be represented by capital letter T. Length, mass and time. Suppose I want to write the dimensional formula of a velocity. Dimensional formula of velocity. What is dimensional formula? First you see this example, thereafter I shall make it clear. Suppose I am writing velocity. This is displacement upon time. Displacement by time. Here displacement is the length. Means length by time. Length I can write L, time I can write T or L T to the power minus 1. This is the dimensional formula for velocity. Or we can write or m to the power 0 L T to the power minus 1. L means L to the power 1. Here m to the power 0 means 1. L to the power 1 means L. T to the power minus 1. This is the dimensional formula for velocity. Then what is the dimensional formula? It is nothing but the expression of a physical quantity in terms of a fundamental quantity or fundamental quantities. So I can write that the expression of a physical quantity the expression of a physical quantity in terms of fundamental quantities are called dimensional formula. Expression of a physical quantity in terms of fundamental quantities are called dimensional formula. So just I wrote that velocity m to the power 0, L to the power 1, but T to the power minus 1. You can write like this. Okay. Generally 1 means we don't write. If you write also nothing will happen. Okay. So here I have expressed the velocity in terms of length, time, mass not there. You can write formally. We used to write MLT all together. That's why written m to the power 0, L to the power 1, T to the power minus 1. So this 0, 1, minus 1, these are called the dimensions of the physical quantity, or I can say these are the dimensions of velocity. Okay, the power to which the fundamental quantity raised are called the dimensions of that physical quantity. So these are the dimensions of a velocity. So the physical quantity which expressed in terms of fundamental quantities, we say dimensional formula. Today's our topic regarding the dimension and dimensional analysis. Especially I am telling about the now dimensional formula. Let us see some more formula. How to find dimensional formula for acceleration? The question is that to find the dimensional formula of acceleration. To find the dimensional formula for acceleration. Let us see. So at first we have to select the formula. Second, the formula we have to. What are the steps? First step. Step 1. Select the formula. Select the correct formula. Second step. Step 2. Express the formula in terms of fundamental quantity. These are the two steps. So let us see. So what is the solution? Find the dimensional formula for acceleration. So I can write acceleration is equal to change in velocity by time. Change in velocity means final velocity minus initial velocity. So the result will be the velocity. So what is the dimensional formula for velocity? Sorry, yes, dimensional formula velocity m to the power 0, L to the power 1, T to the power minus 1 divided by time means T. So I can write m to the power 0, L to the power 1, T to the power minus 2. This is the dimensional formula for acceleration. The question was that to find the dimensional formula for acceleration. We got m to the power 0, L to the power 1, T to the power minus 2. This is the dimensional formula for acceleration. Okay. So before that I said about the velocity, that was the displacement by time. That's why I expressed directly here m to the power 0, L to the 1, T to the minus 1. This is the dimensional formula of velocity. This is the dimensional formula of time. So velocity by time, I got m to the 0, l to the 1, 10 to the minus 2, which is the dimensional formula of acceleration. One more example you see. To find the dimensional formula of force. To find the dimensional formula of force. To find the dimensional formula of force. Okay. So at first we have to select the formula of force. We know that force is equal to mass into acceleration. Okay. So in place of mass I can write m. In place of acceleration just I wrote m to the power 0, l to the 1, t to the power minus 2. That means this is equal to m, l to the power 1, t to the power minus 2. Force is the product of mass and acceleration. Mass is a fundamental quantity. I have expressed with m. Acceleration, its dimensional formula just I found out before, m to the power 0, l to the 1, t to the minus 2. So now the dimensional formula of force is m l to the power 1, t to the power minus 2, or you can write m l t to the power minus 2. This is the dimensional formula for force. So children, I hope that you might have subscribed my channel. If you have not done, do it as early as possible. At the same time, don't forget to share this video with your friends. As a result, they can also get the benefit. Now, I am going to give one more example. So next question, find the dimensional formula of specific heat using the formula Q is equal to ms delta T. What I have to find out? I have to find out the dimensional formula for specific heat. Means I have to find out the S. We know that here Q stands for the heat, M for the mass, S for the specific heat, delta T for the change in temperature. Here Q stands for the heat, M stands for the mass, S stands for specific heat, delta T stands for change in temperature. Okay, so let us see. Is I am writing Q is equal to ms delta T, implies that S is equal to Q by m into delta T. Okay, I said already Q stands for heat, m stands for mass, delta T stands for change in temperature. Okay, So, at first I want to find out the dimensional formula of heat. So, dimensional formula for heat is equal to dimensional formula of energy. Okay, so we know that energy is equal to work. Work is equal to force into displacement. Okay, so I can write that force is equal to mass into acceleration into displacement. Mass we can write m. Acceleration, change in velocity by time. Okay, change in velocity by time. That means m to the power 0, l to the power 1, t to the power minus 2. Acceleration. See that previously I wrote velocity displacement by time, L t to the power minus 1. Acceleration change in velocity by time, L t to the power minus 2. For mass I have written m, and for displacement I am writing L. That means this is m L to the power 2 t to the power minus 2. This is the dimensional formula for energy. Okay, that means dimensional formula for Q I got a L to the power 2 t to the power minus 2. Next, dimensional formula for, see that here I am writing dimensional formula of heat Q is equal to, formula for specific heat. Specific heat is equal to Q by m into delta T. Q is the energy. We got m L square t to the minus 2 divided by m delta T. This is K. Okay. So here mass into acceleration I wrote m L square t to the minus 2, energy divided by mass into change in temperature. Temperature expressed in Kelvin I have written K, mass m. So m cancel. So this is equal to L to the power 2 t to the power minus 2 k to the minus 1, or I can write m to the power 0, L to the power 2 t to the minus 2 k to the power minus 1. Okay, so this is the dimensional formula for specific heat. I hope that you might have understood this class. So in my next video I shall explain some more dimensional formula and its applications in a different field. With the help of a direct dimensional formula, we can check whether a formula is correct or not. With the help of a dimensional formula, we can convert SI system into CGS system or CGS system into SI system. Many more things we can do. So the things what I said I shall discuss in my next video. Until then, bye.